A really interesting question we have here. We are to find the resistance R in this circuit. So we're given a 9 volts power supply, a DC power supply, that causes a current of 1.95 ampere to flow through this total resistance here. So if this is the resistance offered by the circuit that allowed a current of 1.95 ampere to flow through, then if we get the total resistance, we can equate it to the sum of all these resistances and obtain R. This is what I mean. The first thing we want to do first is to calculate the total resistance offered by the circuit. And from Ohm's law, voltage is equals to current times resistance. If we make the total resistance R subject of the formula, we have that the resistance will be equal to the voltage all over the current, where the voltage is 9 and the current flowing through the circuit is 1.95. So let's divide. R will be equals to 9 divided by 1.95, and that is equals to 4.62 ohms. What it means is that the total resistance offered by the circuit here should be equal to 4.62 ohms. So if we are able to add up all the resistance, including R, and equate it to 4.62, we can be able to obtain R from it. However, the sum of the resistance is not the algebraic sum because resistors don't add up that way. First, we need to understand the connection of the resistances, whether they are in series or in parallel. The first one we've identified here, or the obvious one, is that the 3 ohms resistor is in parallel to the 12 ohm resistor. The reason being that as the current is flowing, when it gets to this node, it's going to split. Wherever a current splits denotes parallel connection. So it means these two are in parallel, while this connection, this combination, and these are in series. So let's resolve this parallel connection first. So let's do 3 ohms parallel to 12 ohms. If you have two parallel resistances or resistors, the total resistance is equal to the product of the two resistances divided by the sum of the resistances. So 3 times 12 gives 36, divided by 3 plus 12 gives 15, and that gives us 2.4 ohms. In other words, we can replace this parallel combination with 2.4 ohms so that we now have 2 ohms, 2.4 ohms, and R in series. And recall, for series resistance, you can do the algebraic sum. So the total resistance of the circuit R will be equal to 2 plus 2.4, because 3 ohms and 12 ohm will be replaced by 2.4, plus R. Now let's put in the values. R, the total resistance, is 4.62, equals to 2 plus 2.4 gives us 4.4, plus R, and from here we can make the R subject of formula to become 4.62 minus 4.4, so that the resistance we're looking for will be equal to 0.22 ohms. And that is the answer to the question. Very, very simple, and it is clear enough. If you understood this, then try this simple one. Read the question, solve it, and put your answer in the comment section, and I'll be there waiting for you. Thank you for watching this video.